Yeah, this is Ccie. Good evening, everybody. I'll be rolling out this course. I'll be rolling out this course for Ccie Enterprise Infrastructure version 1.0 that is coming up. Cisco moved the exams from being live on the 24th of February 2020. Now it's going to be live from sometime in April. I don't know the particular date. So that being said, I'm going to be rolling out tutorials, and I will not really call them tutorials. I'll just call them guides to all of these topics. I think I'll use a red pen here. Yeah, guides to all of these topics. So the good news is RIP will no longer be covered in the exams. So goodbye to RIP. Goodbye RIP. But we have always loved RIP. We used it to learn back in the days that we are studying for the CCNA. But no more RIP as of now for the CCIE level. But for the young guys that will be coming to my channel, I'm going to cover RIP as well. Cover the basic initialization of RIP, what passive interfaces does. Basically the things I will cover on AIGRP about RIP, I will do the same for RIP, but at a very high level overview, or a few overview, and also implementation of how RIP works. We'll talk about AIGRP in detail. We'll talk about basic initialization of AIGRP. We'll also talk about passive interfaces, AIGRP feasibility condition. What is AIGRP feasibility condition? There is basically the way AIGRP will know whether it will install a secondary route. Let's say this router knows about network X. Let's call it router 5 has advertised to router 1 about network X, and also router 6 over here also advertised the same network X to router 1. Now router 1 is getting two different routes to router X, so it picks a successor route. That is what the AIGRP will call it, a successor route. A successor route is just a route that is installed in the routing table. But AIGRP also picks what is called a feasible successor. What does a feasible successor route do? Once, let's say that R1 has picked the route via R6 to X as the best route, so that is the route that has made it to the routing table. So if R1 wanted to go to network X now, it will be from R1 to R6 to network X. Now this is the best route, but also R1 in its AIGRP topology will include the route from, I did not label this router, let's call it R2, and let's call this R3. We'll have the route via R2 to R5 to network X in this topology table. Now AIGRP has to check the feasibility condition for this network X via R5, whether it will be installed in its routing table with no negligible delay. No negligible delay if router 1 loses this link to router 6. So what is the condition that will make AIGRP install this route and make it a feasible successor? We discuss that in detail. We'll talk about it. I'll show you why AIGRP will install or why it will not make it a feasible successor. And even if AIGRP does not make a route a feasible successor, it does not really matter, as it doesn't mean it will discard the route. The only difference is that AIGRP will not quickly take that route into the successor state once it loses the link to its successor route. That's just the difference. We'll talk about that. We'll talk about AIGRP stop feature. We'll talk about AIGRP name mode. We'll also talk about AIGRP authentication, as that now AIGRP in the normal AS mode that we configure or that we implementation will accept MD5 authentication, but when you use name mode, Cisco also allows for SHA authentication with SHA. So we'll talk about AIGRP in great detail. From basically, we are going to be talking about this from basic level. I mean, we are talking about basic initialization here up to expert level. We'll discuss all of this on AIGRP. We'll discuss the same. After AIGRP, we'll talk about OSPF basic initialization, how OSPF behaves in different media. We'll talk about the different OSPF network types, point-to-point, OSPF point-to-point, how OSPF behaves in a broadcast media, how OSPF behaves in point to multi-point. There is also point to multi-point. We'll discuss all of that in full detail. When it comes to OSPF, we talk about the different type of areas that OSPF has. We have the normal areas, we have stub areas, we have the not so stubby areas. We'll talk about the different LSA types. LSA type 1, type 2, type 3, type 4. Type 5, we'll talk about all of that and how the routes between OSPF is propagated. We'll talk about summarization. For OSPF, summarization can only be done at the ABR and also at the ASBR. So you can only summarize OSPF being a link state protocol. I'll tell you, I'll talk about why summarization can only be done at the ABR and the ASBR, the difference why it happens like that, whereas at AIGRP you can just summarize at any link at any point. Summarization in AIGRP is any arbitrary point you can just summarize for AIGRP. We'll talk about ISIS, not in great detail. It will be coming up in great detail in my Ccie service provider course that will be coming up after I have completed my Ccie infrastructure lab exam. We talk about redistribution, the basic things that happen with routing protocol redistribution. Basically, this will be redistribution between these routing protocols. We talk about single point redistribution, talk about multi-point redistribution, what are the issues that can come up with redistribution. We also talk about IPv6. IPv6 is really hot on the market now, so we're going to really see how the different addressing schemes for IPv6. We have the link local addresses, we have the global addresses, we have the unique I think it's site local IPv6 addresses. We'll talk about unicast routing in IPv6, talk about running all of these IGPs in IPv6. Basically AIGRP will do that in IPv6 for IPv6, OSPF version 3 for IPv6. We'll look at ISIS, we'll also look at BGP BGP v6 when we get to the BGP section. We'll do a lot for BGP, and while we'll be on BGP, I'll cover route maps and how they work. During the IGPs, we are going to cover ACLs and prefix leaks, the difference between these two things and how they work. Once that is done, I'm going to move straight down to VPNs. We'll talk about GRE, we'll talk about LAN-to-LAN IPsec VPNs, we'll talk about GRE over IPsec. What is the drawback of site-to-site? When I say LAN-to-LAN, it means just a site-to-site VPN. What is the drawback of this type of VPN? What will GRE do for us if we use GRE? We also talk about static virtual tunnel interfaces, what they will do for us in this type of VPN, the drawback that we had with GRE over IPsec. SVTIs are actually brought a solution to that drawback. We'll talk about MGRE, we'll talk about DMVPN, both for phase 1, phase 2, and phase 3. We'll talk about the single hop. DMVPN is simply a technology that you can use to connect your different sites together via usually it's the internet, but actually what you need is basically IP reachability, and you can connect all of your sites together. And we'll talk about it. We'll talk about having a single hop DMVPN. We'll also talk about having it's basically hub and spoke, and where these are all spokes. We'll also talk about dual hop DMVPNs. We'll look at that. We'll look at Flex VPN, Get VPN, IGE version 2. We'll look at that. After that is done, we'll move straight to MPLS. We'll look at MPLS unicast routing with LDP. We'll look at that. We'll look at separating traffic with VRF. And at this point that we'll be talking about VRF in this part, we'll talk about VRF Lite. Yeah, during the MPLS, we'll also discuss process switching. We'll talk about self-switching and what it does for MPLS. We'll talk about route distinguishers, route targets, and what they do for us. I will talk about in detail inter-VRF communication using route leaking. You see that is, I don't know if you are listening to me now whether you know MPLS or not, but stick on with the channel. By the time we are done, you are going to know OSPF, you are going to know MPLS at the tip of your hands. But what it simply does is, let me say I have this router. Let's say this is our P router and this is our P router, and we are now connected to customer A site 1, and we are also connecting to customer A site 2 over here. Let's also say we are talking about inter-VRF communication using route leaking. So let's also say we have a customer B connected here. Now we also have this, and using VRF we are going to separate this customer's traffic from this customer. So that means the traffic for A does not in any way leak to B under normal circumstances. But what of a case where these two companies, company A and company B, has decided to share routes together? They have decided to share some routes. So we are going to see how that will, yellow does not work well because it has a wrong color. So We are going to see how that will turn out for us. We'll do route leaking. After that is done, we'll also do the normal layer 2 topics. These are layer 2 topics. Everybody should be familiar with VLANs, but if you are not, I'll explain that, explain port types. We'll do VTP, we'll have VTP 1, version 1 up to all the way down to version 3. We'll talk about STP, we'll talk about the common STP known as 802.1d. We'll talk about RSTP 802.1w. Talk about MSTP. This one is 802.1s. Why not letting go of Cisco's implementation, which is actually PVST, per VLAN spanning tree? We talk about mapping physical topologies to logical topologies. For example, you can see, let me say for example, this is where, let me say I can have three routers connected to this switch. Router 1, router 2, and router 3. And now I have this kind of topology, but this is the physical connection, but the logical connection, let's say here is physical. Let's say here this side is what? Logical. So in the logical part of things, I can have router 1 directly connected to router 2. I can also have router 1 connected to router 3, and router 2 also connected to router 3. I can have this. If I added another router here, let's call that router R4, I can have router 1 directly connected this way, R4. I can even have router 2 also come to connect router 2. But we'll look at physical topologies and how we can get a different logical topology. After that is done, we'll move straight to quality of service. Quality of service. After we must have implemented all this, it's time that we'll put some QoS, we'll put some policies to our network, to our infrastructure. How are we going to mark packets? We'll talk about marking. Quality of service, we'll talk about classification of traffic and what it helps us do. We'll talk about bandwidth reservation. We'll talk about congestion management. When we talk about congestion management, that's when we start looking at class-based weighted fair queuing. That's what that stands for. WFQ means weighted fair queuing. We talk about low latency queuing and what it does, how do you use it, when do you use it. We talk about congestion avoidance. When you are talking about congestion avoidance, that means you drop some traffic even before they get to the interface that is already congested or that is about to get congested. You select traffic that should be dropped. This is red and red. This one is actually funny, but this is a random. It means random early detection, and this is weighted random early detection. So we are going to be looking at all this. After that is done, CCIE infrastructure is including a lot of good stuff for us, the things that are now being used, that we are meeting daily now at the enterprise level. So I will discuss about SD access in detail, how SD access works. Simply, this is a controller based controller based rollout for our enterprise network as we know it. So we have a DNAC that will do the controller based function. This DNAC works just like ACI for people that are conversant with data centers architecture. That's what this DNAC does. We'll look at the topology. I'll show you in a bit my PowerPoint here for this classes that we are going to be learning together. I know most of this. Very well. I have very strong knowledge on these things, but I want to just reiterate, teach myself, and also teach others that will help to solidify what I know. I like teaching. I love teaching a lot. I've been doing a lot of teaching from a young age. From my CCNA days, I've taught CCNA guys. I've encouraged people to learn, but this time my job does not allow me to do the normal classroom teaching. So this way I can solidify, and my friends also that are saying teach me, they are going to be learning a lot from these videos, trust me. Okay, now we also look at SD1. For SD1, actually Cisco acquired a company that is I think it's Vitpela, Viptela, but it's something like that for their SD1 stuff. Basically, you're going to have a vManage that manages all of this. You have vSmart, where vSmart is I think it's the control plane that will be doing the routing jobs, but we'll look at this in detail. I'll take a look at it and solidify my understanding here. Before we even get here, I'm presently studying SD access in detail and how it's going to work. We also look at Python and some writing scripts for network. That one is not here, but we are going to look at it. So let me pull up my PowerPoint. So this is my PowerPoint slide for the enterprise infrastructure, and this will just show us what we'll be going through. These are all the topics we are going to cover. We are going to cover also Python. I have a background in programming. I write in C++ as well as Java, but I preferred networking as a career. I'm more passionate about networking in general, so I still have my background. So we'll look at this Python and how we are going to integrate it into our network. We'll talk about this you have seen already, IGPs. We'll talk about EIGRP and all that is needed to talk about there. We'll talk about OSPF. We'll talk about IP routing, IPv6 routing. We'll talk about how it's going to benefit us. Talk about Ethernet switching. We talk about software defined access. What does it work? Then look at the diagram. Look at the diagram for software defined access. So the DNAC here, the DNAC that you see here, first table color. Okay. This DNAC that you see here, will be the guy that is doing all of the controller based rollout for configuring our underlay. Basically, these are our edge switches on the enterprise, and these borders represents our exit from the network. look at all these links. We are going to have links this way. In our underlay, we are going to run a routing protocol. You can configure any one of your choice. You can configure OSPF, ISIS. You can also configure EIGRP, any one of your choice. But if you let the DNAC come and discover all these devices, all the fabric, if you let the DNAC do the PMP means plug and play. So basically, you are going to this switch is the 9K, the 9000, the 9K series switches that will allow for controller-based management and configuration. So if you allow this DNAC to be the one to discover these switches and configure the routing protocol that this switch, our underlay will run, will be ISIS, integrated system to integrated system. But if you do the configuration by yourself, you have the choice to actually choose any language of your choice. The control here will be Lisp. So let's say I have a guest here and a guest here. Okay, this will be coming up in our enterprise story, but let me finish my train of thought here. Let me say I have a guest here, A, and a client A and a client B here. When this man wants to reach this man, what does he need to start to build this packet? Let's say his IP address is 1.1.1.1.1 slash anything, and this guy is 2.2.2.2, right? Remember our old packets. So this man has his source IP address as 1.1.1.1, going to where destination IP 2.2.2.2. Let me clear this screen so you can have a better place to write. And I'll use red. So building the packet for this guy, we have a client A here and client B here, and this guy is going, this guy's IP is 2.2.2 1.1.1.1. so begins to build this packet. This is 1.1.1.1, source IP heading to 2.2.2.2. In our old way, we are going to first of all determine what is our source MAC address. So let's say our source MAC address is A, whatever that is. But we always lack this final part, which is what the destination MAC address, to say where this packet is heading to and how we are going to treat this market. So what does this guy do? He's going to use app to resolve the MAC address of this. So he actually will send this packet, seeing that they are not in the same network, to his gateway. His gateway being a router that knows in his routing table how to reach the 2.2.2.2 network or .0 network, anything. To reach that, will get that, return that with his with this guy's MAC address, and now this guy has a way to reach that guy. But now this is not, we are not going to be using app is gone. Instead, we now have a control plane here. This C actually stands for control plane. The control plane will be managed by a protocol named Lisp, and this Lisp we keep a directory, and a clean directory of all the nodes in the network and how to reach all of them. So what does 1.1 do when he wants to go to 2.2.2.2? He sends his packets, and this guy knows how to get to the control protocol to say, I am going to 2.2.2.2. How do I get there? Meanwhile, all these have been configured with loopbacks on the IGP that we are running. So this guy knows how to reach all loopbacks and know where they are and where all these have been located on the network. Remember how switches work, that once you are connected to a switch, in a few minutes the switch learns your what MAC address. So we will say this address 1.1.1.1 with MAC address, doesn't even learn the address, it just learns the MAC address A.A.A is associated with port fast Ethernet 0/0 or 0/1 for a switch. Instead, now Lisp does the job to now say this is where all the nodes are located, and if you are going to 2.2, it is located at this node, so that this man does not need to do no app to reach his destination. He knows how to reach this guy because this guy is already been forwarded by him by Lisp and he just goes like that to him too. Right, it's going to be interesting. The eyes here is here for segmentation and rolling out security policies of who can reach who can access what. That's what eyes stands for. Control is for Lisp. Border here decides how we leave our network. We have the known border and unknown border. We'll talk about all of this in detail when we get to the SDSS session. I'm still studying this so I can be able to teach it properly. I'm just giving you a flyby overview of the way it's meant to work. After that, we head straight to SD1. We talk about SD1. We talk about the different things that is coming up on SD1. This is really interesting because this is the future. This is the future of networking. This is really the future. I'm excited. I'm really excited for the enterprise infrastructure. So I hope you join me. Just join me as we study. Or anytime you see this video, I hope you are able to learn from it. All these things are what we have already covered in the Word document. So we'll do this. So what I will say is, having said all this, the videos will be rolling out on my channel. So stay tuned. If you are not subscribed, subscribe so that you don't miss a video as we learn together. I really love networking. I hope you love networking as much as I do. Well, if you don't love networking, I don't think you'll be watching up to this point. So join me as we begin the journey from beginner. Don't need to have any previous knowledge, just a will and a zeal and a passion to learn, to experts. All the things I know I'm going to pour out here. Thanks, and I hope this video has been informative for you, and I'd like to thank you for viewing.